Now, next topic is continental drift. Continental drift. See, from here pre-related questions will not come. Okay, if at all any pre-questions will be coming, I'll be telling you what. So I'll be doing this topic from the perspective of a pre only. Okay. Now they can ask. See, basically, this guy, whom you see in the picture is Alfred Wegener. Alfred Wegener is a German climatologist. He was studying the climate of Germany and Greenland and Antarctica. He went to Antarctica also. He went to South America also. He was investigating the climate and he found certain climatic anomalies. Anomaly means, okay, it is something opposite of what you expect. He found something different than what is supposed to be there. That is called as the climatic anomaly. So, his Alfred Wegener, okay, when he was investigating in the world, he found some climatic anomalies. So, from that, he has come to a conclusion that continental drift is happening. So, pre में क्या पूछ सकता है? Okay, so इससे आप क्या relate कर सकते हो? You can relate plate tectonics. Now, for the plate tectonics to happen, you need to have a layer called as asthenosphere. So, while discussing the interiors of the earth, I did not discuss asthenosphere because I will discuss asthenosphere here. Because until and unless I don't find a context, I will not discuss. Understood? So, this guy has come up with the continental drift theory. He said that there existed a supercontinent called as Pangaea, and the Pangaea was surrounded by a super ocean called as Panthalassa. Then this Pangaea split into two parts, Gondwana land in the south and Laurasia in the north. Okay, then it was further splitted. So this is from where North America, Europe, Asia has been created, and from the Gondwana land, South America, Africa, India, Australia and Antarctica is created. So this is the present day. So he has given this theory of the continental drift. Now while he was explaining this concept of continental drift, he has used the concept of Sial and Sima. Sial, Sima. So Sial is the continents and Sima is the ocean. So he assumed that the Sialic continents are drifting and floating over the Simatic oceans. Now why he has assumed this? Because he himself was climatologist. इनको climatology के बारे में पता था, geomorphology, geology के बारे में बहुत कम पता था. He has used the concept of Edward Suez. Edward Suez. Edward Suez was a geomorphologist. He gave this concept. So this is like the wooden blocks floating on the water or the ships which are floating on the water. So from there he has taken this concept of Sial and Sima. So he did not know why the continents are breaking or why the Sial is breaking. इनको पूछा था ये क्यों break हो रहा है? He said that when these continents are moving, the leading edge, means ये सामने वाला part, is unable to keep pace with the trailing edge. So पीछे वाला part is unable to keep pace. That's why they are breaking. So he kind of gave very weird explanations, but he is still considered to be the greatest because he is the first one who planted the idea of continental drift. Because before this, people used to consider that oceans and continents are permanent, he is the first one who has planted this idea. That's why he is considered to be the greatest. Okay, I'll tell you what kind of evidences he has presented. He has presented the evidence of jigsaw fit. Because, okay, he said that, even till today, South America and Africa seem to be fitting into each other. So, यहाँ से कुछ, ये मेंस का पार्ट है, प्री में उतना नहीं पूछेगा. That's why I'm rushing here. Okay. He also said that, okay, not only the coastline is fitting into each other, but also the age of the rocks fit into each other. Age of the rocks, faulting lines, these are called as structural evidences. The structural evidences are also matching. Okay. And he also has given the fossil evidences. This is Mesosaurus. ये crocodile का ancestor बोल सकते हो आप. Mesosaurus, okay, is the fresh water reptile. ये सॉल्ट वाटर में जिंदा नहीं रहेगा, फ्रेश वाटर में जिंदा रहेगा. ओके, अब यहाँ के प्लांट्स भी देखो, ये प्लांट्स सारे फर्न्स है. ड्यूरिंग दैट टाइम पीरियड फर्न्स होते थे एंड दिस इज पार्ट ऑफ द इकोलॉजिकल सक्सेशन. अभी के जो मॉडर्न फ्लावरिंग प्लांट्स है तब नहीं था, तब फ्लावर्स नहीं होते थे, ओनली फर्न्स यूज्ड टू बी देयर. सो दिस इज Mesosaurus. Then he also found the Listosaurus. He also found the Synognathus, and you can see all these are reptiles and mammals भी completely evolve नहीं हुए थे. Okay, reptile थोड़ा reptile और mammal के बीच में animals, and definitely this can't swim, but he found the fossils of these animals across the continents. So this is the proof that once upon a time all these continents were together. ये सब साथ में थे and बाद में ये separate हो गए, continents separate हो गए. So that's why you find the fossils of these animals in all these continents. Okay, and he also gave one more evidence, that is the lemmings. The lemmings have a habit of moving from east to west. So when North America and Eurasia was together, they are able to move very far away. But once North America was separated from Eurasia, they did not find any land further. इसलिए नॉर्वे के कोस्ट में आपको बहुत सारे फॉसिल्स मिलते हैं लेमिंग्स का. So this is also one of the proof. So this is the continental drift theory in short. Now later on, one more theory has come, that why the continents are drifting, because Alfred Wegener was unable to explain why the continental drift was happening. Unable to explain. He has come up with very weird explanations. He told that it's because of the gravitational pull of sun and moon. He also told that it's because of the pole fleeing force. So some kind of weird explanations he has given, because बेचारा climatologist था. आप उसको पूछ रहे हो, please tell me, okay, why it is happening? Because people could not believe that. Because all these years they have stayed in a fool's paradise. इतने लोगों से people believe करते थे कि oceans and continents permanent है. अब suddenly आके कोई कुछ बोलता है कि no, you are wrong, अब बेवकूफ हो, इतने दिन से आप एक lie में believe कर रहे हो. Okay, continents and oceans actually move. कौन है ये पागल आ गया, ऐसा बोलेंगे ना. सो वेगनर को भी बेचारे को ऐसे ही बोला था, ये पागल है, कौन आ गया, ऐसा क्यों बोल रहा है. ओके, देन उसने प्रूफ दिखाया सारे. सो दिस आर द प्रूफ्स. प्रूफ दिखाने के बाद लोगों ने पूछा, चलो मान लेते हैं, बताओ रीजन क्या है. बेचारा कहाँ क्लाइमेटोलॉजिस्ट, उसको अर्थ के बारे में क्या पता था. दैट्स व्हाई ही हैज कम अप विद वियर्ड एक्सप्लेनेशंस. So though he has come up with weird explanations, we'll excuse him there, because he was the first person to lay the foundation for the plate tectonics theory. मतलब सोच तो डाला है ना लोगों के मन में कि continents and oceans are not permanent. That's why he is considered to be greatest. Okay. Then came Arthur Holmes. Arthur Holmes after Wegener. Wegener के बाद Arthur Holmes आया, and then he has come up with, here you have to excuse me because I have to use a video here. बीच में अगर ad आएगा then excuse me for that. आपको अच्छी तरह समझ में आ जाएगा. It's a very small video. So then Arthur Holmes has come. So Arthur Holmes has explained why the earth has moving plate tectonics. Okay, what is the reason behind the moving plates? Okay. Okay, somebody is asking me a question. Amit is asking, if he was wrong, but how people knew he is wrong while no one knows about it? You're asking me philosophical question here. I'm very bad with philosophy. Okay. If he was wrong, how people knew he was wrong? अरे भाई लोग एक गलत चीज़ में बिलीव कर रहे हैं. फॉर एग्जाम्पल यू आर बिलीविंग इन समथिंग विच इज़ फॉल्स. कोई आके बताएगा भाई तू बेवकूफ़ है, तू इसमें बिलीव कर रहा था, देन यू विल डिनाई हिम ना. वैसे आर्थर होम्स को अल्फ्रेड वेगनर को बोला था ऐसे कैसे होगा, राइट. पीपल डोंट वांट टू बिलीव दैट दे आर फूल्स ना. अंडरस्टूड. Now there is lot of heat inside the earth. This heat has to be dissipated outside, and this heat energy is dissipated with the help of these mantle convecting cells. So look the way it is rising. So the molten rock is trying to come out, and these are called as the mantle convecting cells. Arthur Holmes is the first person who found this. So the molten magma, so molten rock which is magma, is rising up. When it comes up, it will be cooled, again it will be going back. So this is called as the principle of the mantle convecting cells. So next, Arthur Holmes has given the principle of MCC, mantle convecting cells. It is nothing but the process of convection. So this is how the heat is released. Heat is released. Now this is responsible for plate tectonics. So this is the lithosphere, and below the lithosphere you have this mantle convecting cell. This is called as a rising limb. This is called as the sinking limb, and this is called as a diverging limb. So when this limb is diverging, it is dragging this lithospheric plate above. इसको drag कर रहा है, like it is shown in the picture here. So when this is moving, so this lithosphere plate is being dragged. Okay, and here you will be having the divergence. Okay, so here the rift valley will be created. Rift valley will be created. Okay, so this theory has been given by Arthur Holmes. Then first came the Wegener. So Wegener has given the Continental Drift theory, 1912. Then Arthur Holmes 1930. Then seafloor spreading hypothesis. Seafloor spreading. This is given by Hess and Dietz. Then further, okay, this has happened in 50s and 60s. And further, it has laid foundation for the plate tectonics theory. See, I will not be discussing this also much. I'll discuss 2 points which are very important here that I can discuss in plate tectonics theory also. Okay, I'm not discussing theory here. Then came the plate tectonics theory. This theory is still continuing. This was developed in 60s and 70s. So this has been given by the people like Mackenzie, Wilson, etc. And this theory is still continuing. See, before 1912, okay, before 1912, people believed that oceans and continents are permanent. So Wegener has told that no, it is not permanent. Finally, we are believing in plate tectonics theory. Is the plate tectonics theory completely true? We are believing in this now. It might not be completely true, but it is able to explain most of the phenomena. Understood? Now, if you know this, then we will always give a benefit of doubt to those statements. तो यूपीएससी में जो भी स्टेटमेंट आएगा, आपको अगर पता नहीं है, इसका मतलब नहीं है कि वो नहीं होता है. आपको सोचना चाहिए ये क्यों नहीं हो सकता है. Okay, understood? Based on this logic, now you will be able to solve at least 10 questions. Understood? So many comments here. Yes, very good, Shubhajit. Okay. Yes, Galileo is also victim of that. Yes, you are right. So next comes the plate tectonics theory. PTT, plate tectonics theory. So plate tectonics theory is based on the assumption that there are numerous plates. Okay, there are numerous macro plates, micro plates, okay, or major plates, minor plates and micro plates. Small plates are also there, right? And these plates are placed on the asthenosphere. So the crust, this is the continental crust and this is the oceanic crust. The continental crust and oceanic crust is floating on a layer called as asthenosphere, and the depth of this asthenosphere is around 400 kilometers. And the depth of this crust plus the upper part of the mantle, this is crust and upper part of the mantle, this is called as the lithosphere. Now these plates are made up of the lithosphere, okay, which is, and these lithospheric plates are floating over the asthenosphere, okay. So these are these plates. So just now I have shown you this Scotia plate is located here. This is the Indian plate, this is Australian plate, and this entire Indonesian part, Indonesia, Malaysia, Philippines, all these are part of the Eurasian plate, though it has lot of micro plates also. And these plates have 3 types of interactions. Okay, this is the transform plate interaction, means these plates can move side by side. This is divergent plate boundary. Here the plates are moving away from each other. This is the convergent plate boundary. Plates are moving towards each other. That means here the people are getting into relationship. Makeup हो रहा है यहाँ पे. Plates are moving away from each other. Breakup हो रहा है. यहाँ पे क्या होता है? यहाँ पे plates are just sliding past each other. That means you people are moving just side by side, but not talking to each other. So यहाँ पे कुछ नहीं हो रहा है. Side by side move कर रहा है. That's why this is also called as the conservative plate boundary. This is also called as conservative plate boundary. So this is a divergent plate boundary. Plates are moving away from each other. So when plates are moving away from each other, new oceanic crust is created. Construction is happening. That's why it is also called as constructive plate boundary. So called as constructive. आपको याद नहीं रहता है तो ऐसे याद रखना, जब आपका ब्रेकअप होता है, एक दूसरे से दूर जाते हो आप, लाइफ में क्या होगा? कंस्ट्रक्शन होगा. आईएएस बन जाओगे आप, आईपीएस बन जाओगे. वो मुझे छोड़ के चली गई, चलो मैं कुछ बन के दिखाऊंगा. लाइक दैट. सो दिस इज कन्वर्जेंट प्लेट बाउंड्री. इफ यू आर प्रिपेयरिंग फॉर सिविल सर्विसेज, यू आर गेटिंग इनटू रिलेशनशिप, क्या होगा लाइफ में? दिस इज डिस्ट्रक्टिव प्लेट बाउंड्री. सो प्लेट टेक्टोनिक्स के भाषा में, इफ देर इज ए ओशियनिक प्लेट इन बिटवीन, if the plates are moving towards each other, the oceanic plate will undergo subduction, it will undergo destruction. So this construction, destruction is with respect to the plate boundaries, oceanic plate boundary, whether the oceanic crust is being created or the oceanic crust is destroyed. Understood? So somebody is asking, Maitri is asking how to remember the names of the plates. Yeah, जरूरत नहीं है सारे plates का नाम याद रखने के लिए, especially for prelims जरूरत नहीं है. कौन सा याद रखना है, I'll tell you. Okay. Okay. इंडियन ओशन डाइपोल करेंगे, बाद में करेंगे, उसका टाइम आएगा. वेट फॉर सम टाइम. So this is the divergent plate boundary. So वोल्केनोस में क्या क्या याद रखे, I'll tell you क्या क्या याद रखना है. Anatolian plate, yeah, I will discuss in detail, don't worry. अच्छा, आपने मेरे स्टूडेंट्स हो तो आप ये सब जानते होंगे चीज़ें. So this is the divergent plate boundary. So initially क्या होगा, initially the magma will be coming out, because of which a rift is created, and this will create a rift valley, and this rift valley will be filled with the water, and it will be creating a rift valley lakes. Now exam के लिए क्या important है, क्यों important है? So exam के perspective से they might ask you the Rift Valley lakes in Africa. So right now the Africa or the Great African Rifting is in this stage. So you'll be having lot of rift valleys. You can see here. I can show you with more clarity if I use Google Earth. So here you have more clarity. Now why the Great African Lakes are important? Because, okay, according to Global Crisis Group, so Africa is one of the hotspots where a lot of fights are happening, a lot of conflicts are happening. And right now in Sudan, there is a bloody conflict going on. between the army itself. One is paramilitary, other is the army. दोनों के बीच में fight हो रहा है. So that's why these Great Lakes are also important. As far as geography is concerned, they'll be asking you, and nowadays they are asking the locations which are in conflicts. I'll be covering all those regions in the world which are under conflict. Yes, Maitri, yes, only the oceanic crust is created and destroyed. Continental crust is permanent. Okay, Akhilesh, bilingual. Okay, thank you. I'll use. Yes, Swami, oceanic crust is subducted, not subsided. The word is subduction. Yes, okay. So this is the thickness of the atmosphere. Anyways, I'll tell you the names of the lakes here. So this is Lake Malawi, also called as Lake Nyasa. Here you have Lake Tanganyika. You have Lake Kivu, Lake Edward, Lake Albert, and this is continuing here. And here on this side you have Lake Turkana. You have to remember the names of the lakes and please mark these lakes in your atlas. All these are Rift Valley lakes. In fact, in last year prelims they have asked about Lake Victoria. Now Lake Victoria, which is in between this lake, this is not a Rift Valley lake. Not a Rift Valley lake. I'll tell you some of the properties of these lakes. So these lakes have a very high alkalinity. They have a lot of minerals. They are rich in fishes because of the growth of the phytoplanktons. And since these lakes are created because of the rifting of the earth, since these lakes are created because of the endogenic forces, these lakes are very deep. For example, you take Lake Tanganyika. Lake Tanganyika is the second deepest lake in the world. The first one is Lake Baikal. The Lake Baikal is located in Russia. Its depth is around 1620 meters. So this is around 1550 meters. The second deepest lake. And remember this, wherever you'll be having deep lakes like above 500 meters, above 1000 meters, it also means that they have been created because of rifting. They have been created because of divergent, or once upon a time they are the plate boundaries. Okay. And Lake Victoria is not a Rift Valley lake. Okay. Now this is the rifting which you can see. This is more clear, but it's not opening. So this is the rifting which you can see. So on the either side of this, you have Ethiopian highlands. Ethiopian highlands है यहाँ पे. So Ethiopian highlands are the basaltic eruptions, just like the Deccan lava plateau. And in the northern part of the Ethiopia, here this region is called as Tigray region. Okay. And below Tigray, you have one more region called as Amara region. I'll not talk about this. Anyways, last year the question has been asked from here. The Tigray region was in conflict with the government of the Ethiopia. Here he had rebels. So Tigray people, okay, against Tigray people, there's a different ethnicity here. A lot of atrocities were committed by the government of Ethiopia and also the government of Eritrea. So the people have fled. The people, okay, had migrated, okay, as refugees, as asylum seekers away from the Tigray region into the neighboring countries. Okay. So since Ethiopia has come, I told you this. Now at the end of this great African rifting, so this is the great African rifting. At the end of this great African rifting, you have a region called as Danical Depression. So this is how the Danical Depression looks like. So Danical Depression is the most inhospitable place on the surface of the earth. ये याद रखना, Danical Depression. And this great African rifting is extending into Red Sea, and this is also extending into the Arabian Sea, and between these, this is called as Afar Triple Junction. Afar Triple Junction. So triple junctions are those locations which are located between three plates. So here you have Nubian plate. On this side you have Somali plate. Here above you have Arabian plate. And Afar Triple Junction is also hot spot. So generally UPSC focuses on those parts which are in the news recently. Africa is in the news, Ethiopia is in the news, Djibouti is in the news, Somalia is in the news, Sudan, I'll talk about the Sudan conflict also. So इसके आसपास जितने भी geographical features है उनका ध्यान रखना है. Okay? Yes, Lake Kivu is also part of it. So which African lake dried recently, but it's not completely dried, but it's drying very fast. Lake Chad, it's located in the country Chad. It is drying very fast. Yes, Lake Baikal is also created due to rifting. Okay. So now Horn of Africa में कौन से countries आएगा? So in Horn of Africa, Eritrea will come, Djibouti will come, Ethiopia will come, and Somalia will come. And Somalia has a terrorist group which is prominent called as Al-Shabaab. So Al-Shabaab is the famous terrorist group in Somalia. Okay. And recently there was a reconciliation. Means talks are being held between the Shia and the Sunni groups. So in Yemen also there was a lot of infighting. Yemen में बहुत लड़ाई हो रहा था. So Yemen you have Houthi rebels. The Houthi rebels belong to Shia group. Okay, and the ruling party, and the ruling is by Sunni. Ruling Sunni, rebels are Shia. So recently there was a reconciliation, there was an understanding between these two. And these Houthi rebels have a very strong hold in a region called as Marib region. Here you have a region called as Marib. Marib region is located in Yemen. Because nowadays how the questions are asked, questions ऐसे पूछते हैं. For example, they will give a location Marib. They will give a location Tigray. They will give a location South Ossetia. They will give a location, say, Catalonia. And they will ask you to match the following. And these are the locations, okay, which are autonomous or which are independent for all practical purposes. Or we can say these are the conflicted regions also. So whenever the locations are coming, whenever the concept is coming, so along with that, if you have any locations, I will mark those locations also. Okay. Now, this great African rifting is also extending into the Red Sea. Yes, Aditya, right. Okay, here Djibouti is there. Djibouti, you have the military presence of many countries. In fact, you can see China, Chinese army, you can see here, Chinese People Liberation Army. If you can read this, the China has got a base here. Not only China, almost all the important countries have bases in Djibouti, because Djibouti is located at the important trade point, a Gulf of Suez के route में, and here in the south you have Somalia. The Somalia has lot of Al-Shabaab group है, piracy के लिए बहुत ही famous है. यमन में हौती rebels है. So and Tigray region again, again instability, again Sudan, again instability. So this entire region is surrounded by a lot of instability. That's why your cargo, your trade needs to be protected. So that's why the countries are having their military bases in Djibouti. So Djibouti is like a prime real estate. China, okay, has established, it's also part of the stings of the pearl policy of China. Okay, understood? So we are here. So I'll be doing map pointing here a little bit. So beach mein na, will keep shifting, it will keep changing. See, this is Red Sea. So the great African rifting is extending into Red Sea, and further from Red Sea it is extending into Gulf of Aqaba, further extending into Gulf of Aqaba. So this is Gulf of Aqaba. So Gulf of Aqaba is the only port of Jordan. So Jordan has a very narrow opening into Gulf of Aqaba. So this can be asked. Okay. Now this is further extending as River Jordan. Further extending as River Jordan. And here in this rifting you have Dead Sea. Dead Sea is further extending as again River Jordan, and here you have Sea of Galilee. Sea of Galilee. Sea of Galilee is also called as Lake Tiberias. Above the Sea of Galilee, there is a region called as Golan Heights. Golan Heights is disputed between Syria and Israel. It is disputed between Syria and Israel. So nowadays Israel is in news for various reasons. Now we'll see this part in more detail. So this is all Israel. So Israel has an opening into Gulf of Aqaba, and further it opens into the Red Sea. And within Israel you have two regions. You have two regions which are also called as Philistine or Palestine. This region, it is called as West Bank. This is called as West Bank. West Bank because it is on the western side of the river Jordan. So, between this West Bank and Israel, the holy city of Jerusalem is there. Holy city of Jerusalem. So, Jerusalem is the home of all Semitic religions or the Abrahamic religions. It's a birthplace of, is considered to be the birthplace of Christianity, the Islam and also Jews. और तीनों के लिए Zoroastrianism, ये तीनों के लिए important holy shrine है. This is West Bank and this is called as Gaza Strip. Gaza Strip. In Gaza Strip, the group, political party, outfit, whatever you want to call it, which is active is Hamas. Okay, and Hamas gets support from Muslim Brotherhood of Egypt. West Bank, in West Bank there is a group which is prominent, okay, which is called as Fatah, F-A-T-H. Okay, you can call it political group, you can go to cultural group, it can some, okay, Hamas has been declared as terrorist organization also. It all depends on the perspective. So, these groups are very prominent. Sometimes in examination they will ask you, match the following groups and countries. Okay. So, this is about the Israel. In Jerusalem, you have Al-Aqsa Mosque. So, recently there have been shootings and firings reported in Al-Aqsa Mosque. So, that is why this region is important. And this peninsula in between, this is called as the Sinai Peninsula. And the Sinai Peninsula is sandwiched between the Gulf of Suez and the Gulf of Aqaba. And Sinai Peninsula falls into Asia, it is part of Asia. On the western side of the Sinai Peninsula, here you have Suez Canal. Here you have Suez Canal. The Suez Canal is acting as a boundary between Asia and Africa. Now, Suez Canal is an important trade route. So, along the Suez Canal, you have lakes. The Suez Canal will be connecting Suez, with Port Said. Along the lakes of Great Bitter, Small Bitter and Timsah Lake. So, these are the lakes. 2 years ago, a cargo ship, it was stranded here, फंस गया था सुएज कैनाल में. आपने एक मीम देखा होगा इंटरनेट में, वेरी फेमस मीम. बहुत बड़ा शिप है, उसका साइड में जेसीबी चल रही है, खुदाई कर रही है शिप को निकालने के लिए, राइट. सो दैट हैज हैपेंड इन दिस सुएज कैनाल. So, these are the locations in this region. Okay. So, this is about the divergent plate boundary. Now, coming back to the presentation. Okay, good Sandeep. See, this is a great rifting. Example of this is Great African Rifting. This is the example of Red Sea. Okay. So, further this rift valley will be opening up and a basaltic ocean floor is created in between, and this basaltic ocean floor marks the formation of the new crust. That is why this is called as the constructive plate boundary, and is further becomes larger, and this becomes mid oceanic region between, and this becomes a mature ocean also. So, Atlantic Ocean is such ocean. Now, the age of the rocks from the ridge towards the continents, the age of the rocks keeps on increasing. Means here you will be having older rocks, and near the ridge, because this is very new. So, here you will be having new rocks. Now, if you take the thickness of the sediments, the thickness of the sediments will be more near the continents, and away from the continents the thickness of the sediments decreases, because the source of the sediments is continent. So, this is about the divergent plate boundary. So, then you have the convergent plate boundary. The convergent plate boundary. The convergent plate boundary can be between the oceanic crust and the oceanic crust, OC and OC, oceanic crust and oceanic crust. So, one of these two will be moving forward, one of these two will be moving forward, one which is heavier and older will be moving forward. So, this has moved forward, say ये आगे move कर दिया. This is OC and this is CC, and this will undergo subduction. So, after it is undergoing subduction, this will undergo melting. Okay. This will undergo melting, and it will be giving rise to the volcanic eruption, and these are called as the volcanic island arcs. Okay. It will give rise to the chain of islands, also called as the archipelagos, and the ocean which is created behind, or the sea which is left behind, because earlier this was part of the same sea, this entire region was the same sea, but now this part of the ocean has been separated from rest of the ocean. That is why this is called as marginal sea. This is called as marginal sea. Since it is located in the back side of this island arc, it is also called as the back arc. This is also called as the back arc, also called as marginal sea. And such kind of volcanoes are highly explosive. These are highly explosive because such magma or lava is sourced from the upper layers, and such kind of lava is highly acidic in nature. It is highly viscous in nature, and the viscous lava does not come out that easily. So, that is why it will be undergoing explosion. So, viscous lava is one reason. Second reason is, when the subduction is taking place, the water will also go inside. So, this water will be going inside, this water will boil, and such kind of volcanism is also associated with high amount of ash, volcanic bombs, lapilli, and these are generally stratovolcanoes. And here you will find the craters and calderas. The explosion of the craters or the collision or the collapse of the craters will create calderas here. So, basically this is very dangerous region, and these volcanoes, since they are highly explosive in nature, they will also trigger a lot of earthquakes. Okay, understood? Okay, good Sandhya. Yes, Shram El Sheikh. Okay, it's in Sinai Peninsula where COP27 was held. Very good, nice. Now, what kind of questions we can expect from here? So, this is that OC part, this is OC part, and this is the CC part. Again, this is OC, and इसके पीछे CC है. And you have this marginal C's which are created. So, all these are the marginal C's or the back arcs. So, this is the Aleutian Trench. These are the Aleutian Islands. Behind this you have Bering Sea. In exam they will ask you the order of these seas. This is Bering Sea, this is Sea of Okhotsk, and recently 10 days ago this is called as the Kamchatka Peninsula of Russia. Since it is located near to the subduction zone, a lot of volcanic eruption is happening. This peninsula has numerous volcanoes, active volcanoes, and these are the Kuril Islands, and this is the Kuril Trench, and Kuril Trench are conflicted between Russia and Japan, दोनों के बीच में. So recently Russia has sent, okay, it is establishing a military base in the Kuril Islands because China is becoming aggressive in this region, Russia is also becoming aggressive, and Japan's power is waning. Okay, it is declining. So that's where Russia is sending its troops. Okay, in Kuril Islands, the military bases of Russia are being established, and there are islands here which are conflicted between Japan and Russia. Now come to Japan. So behind Japan, here, okay, this is called as LOC. This is Sea of Japan. Behind Japan you have Sea of Japan. Beside China, LOC is there. The Yellow River of China is draining into LOC. So just above the LOC you have Sea of Bohai, is also called as Bay of Bohai. In Bohai, China is conducting lot of military exercises, and this is seen as a threat by Korea and Japan both. Now this part, it is called as East China Sea. East China Sea. Now at the bottom of this East China Sea, here you have an island called as Senkaku. Senkaku is the name given by Japan. It's also called as Diagyu. This is a name given by China. So this is also under conflict. Okay. Then below this you have a small island here. This island is called as Formosa, also called as Taiwan. So recently you must have heard that China, it wants to attack Taiwan. Basically the China is just observing, okay, when this Russia-Ukraine war is happening. It is seeing what the world community is doing. When one country will attack other country, what US does, what UNSC will do, or what the UN will do. Basically they are not doing anything about it. So in the next 1 year, if my prediction is right, in the next 1 year you will not see Taiwan on the map. It will become part of China. And between China, mainland China, that's why it is also called as mainland China, and this is island China. Between these two, there is a strait called as Formosa Strait. It's also called as the Taiwanese Strait. Now coming down here, this part. So here you have the South China Sea. South China Sea. Okay. So here you have a trench. This is the Mariana Trench. Mariana Trench. So in the Mariana Trench, you have Challenges Deep, which is the deepest point on the surface of the earth. And beside Mariana Trench, you have an island called as Guam, Guam. Okay, the Guam Islands and Marshall Islands here, they belong to USA. And USA has a naval base here in this region. And beside Philippines, you have Philippines Trench. You have Philippines Trench. So because of the trench, you have these islands created. The Philippines is also archipelago. And this region is the South China Sea. Now within this South China Sea, you have three locations. In the south you have Spratly Island, in the north you have Paracel Island, in the east you have Scarborough Shoal. Scarborough Shoal, Paracel Islands and Spratly Islands. So these islands are conflicted and China is laying claims on these three islands, because if these islands belong to China, okay, if these islands are belonging to China, then China can claim the entire South China Sea using a clause called as archipelagic waters. And the archipelagic waters is under United Nations Convention on Law of Seas 1982. Though China is not part of the UNCLOS, but still it can claim using the subclause called as archipelagic waters. So that is how the China is laying claims in this region, because it's important to China, because it is an important trade route, it's an important sea lanes of communication. So having a presence in the China Sea, South China Sea, can also counter, okay, it will help China in countering the Quad which has been formed in this region. There is a Quad grouping here. So it will be able to counter Quad, Japan, India, USA and Australia. And also new grouping which has been created in this region called as AUKUS, इसको भी counter कर सकता है. And South China Sea also has biotic and abiotic resources, such as fishing resources there here in this region. And there are petroleum deposits also off the coast of Vietnam. And India's presence is there in the South China Sea. India, in collaboration with Vietnam, we are exploring the petroleum reserves. ONDC Videsh Limited, called as OVL, okay, is exploring the resources in this region. Now here Philippines. The Philippines is majorly made up of two islands here, Luzon and Mindanao. Don't have to remember, not required. So that's why I'm telling you only current affairs, which are happening from past 4 to 5 years, so that you can focus on those things only more. Understood? Okay, fine. Now coming to this part here. So this is Guinea Island, okay. It is mostly continental in nature. In Guinea you also have Papua New Guinea. Papua New Guinea is a separate country, and Papua New Guinea, though it is a very small island, it has around 700 to 800 languages which are spoken in this region. There are a lot of diversity in terms of language, because this is densely forested. When you have a dense forest, you will be having tribal groups, okay, who are not in contact with each other, who live in isolation. So when the groups live in isolation, over a period of time, they will develop their own language. Okay. So this is the Sulawesi Island, not important. And this island is Borneo. This island is Borneo, also called as the Kalimantan Island. So this Borneo has 3 countries, okay, Malaysia, Indonesia and Brunei. It is important because the capital Jakarta is located in the island Java. Here you have Java Island, This is Sumatra Island. So, the Jakarta, the Indonesia is ditching its capital Jakarta and it's moving to a new capital called as Nusantara. So, Nusantara will be located in Borneo because the place where the Jakarta is located, it's already a low lying land, it has lot of marshy area, it has lot of what term? Clay area. So, it does not have stable rocks, it does not have granitic gneissic rocks. So, that is why because of the heavy construction, okay, the land is sinking. When the land sinks, the sea level will also rise. The sea level intrusion is taking place, seawater intrusion is taking place, because of which it is shifting its capital from Jakarta to East Kalimantan. Okay. So, this is Java and this is Sumatra. The Sumatra is mostly continental island, Java is mostly volcanic island. So, because it is volcanic island, it has fertile volcanic soils, that is why agriculture is also possible. So, here Indonesia produces around 50% of the world's palm oil, which India is one of the largest importer, and Malaysia produces 40%, means 90% of the world palm oil is coming from this region. There is an island called as Bali here. Bali, it has a lot of Hindu population, it is also a famous tourist location. So, here you have a country called as Timor-Leste, also called as East Timor. Now, East Timor follows Christianity. Okay. So, earlier it was part of the Indonesia, but because of the religious differences, because Indonesia is a Muslim country, so Timor-Leste is a Christian dominated, it has more than 99.5% Christian population. So, because of this, Timor-Leste was separated from Indonesia, in which USA has helped Timor-Leste. So, why you have to remember this, why you have to know this, because the Russia-Ukraine war is happening. In Ukraine, the people who are of Russian ethnic population, Russian speaking population, they want to get separated from Ukraine and they want to join Russia. Now, why USA has a problem? USA has earlier supported such kind of issues. It has supported Timor-Leste when it want to get independent from Indonesia. So, you should know all those locations where USA has actively intervened. Okay. I will come to Sudan. Sudan भी discuss करूँगा मैं. So, since I am discussing OCOC, okay, these are the archipelagos. So, previously in the mains they have asked why Indonesia has too many archipelagos, because if you look at the plate boundaries here, the plate boundaries, so this is Indo-Austral plate, this is Indo-Austral plate, and this is Eurasian plate, Eurasian plate. So, between the Indo-Austral and the Eurasian plate, you have Sunda-Java trench. So, because of this Sunda-Java trench, this is a Sunda-Java trench, the subduction which is taking place, and because of this subduction, numerous islands have been formed. So, not only this Sunda-Java trench, you also have this Philippines trench, and this Eurasian plate has numerous microplates, has numerous minor plates which also have independent movement. वो भी हिलते रहते हैं इधर उधर, जब भी वो हिलेंगे, whenever they move, okay, they will be undergoing subduction, and because of the subduction, numerous islands are created. Indonesia itself, it has around 18,000 small big islands, छोटे बड़े मिला के पूरे 18,000 आइलैंड है. सो इतने सारे आइलैंड्स कैसे फॉर्म होते हैं यहाँ पे? दे आर फॉर्म्ड बिकॉज ऑफ दिस, बिकॉज ऑफ ओशियानिक प्लेट subduction. Okay, now we'll discuss about other such kind of phenomena also. So one which is in the news is this here. Here if you see, this is called as the Tonga Kermadec Trench. Tonga Kermadec Trench. Here you have an island called as Tonga. Tonga. Behind Tonga you have Fiji. Now because of the trench, when the Pacific plate is undergoing subduction, the Tonga had a very huge volcanic eruption. This volcanic eruption was so huge that the crater was converted to caldera. And this explosion was so huge that tsunamis have been created in Fiji. Again, why Fiji is important? Because Fiji has Indian diaspora. So this is important. And this eruption also has given rise to new island here, which I will discuss later. नया island भी create हुआ है. Because so new island will be created because of the volcanic eruption. So this is about OC collision. So next you will be having OC-CC collision. So here in this, the oceanic plate will be undergoing subduction, and on the other side you will be having the continental crust. You will be having continental crust. So when this will be undergoing subduction, melting will be taking place, and after the melting takes place, then volcanoes will be created. Volcanoes will be created. And the accretionary wedge along with the chaotic matter will be uplifted in the form of mountains. Will be uplifted in the form of mountains. So on the edge of the continents you will be having such mountains, and behind these mountains you will be having volcanoes. So this is very similar to the Eurasian plate, and this was the Indian plate, and in between you had Tethys Sea. So when the Tethys Sea was undergoing subduction, imagine this as a Tethys Sea. When this was undergoing subduction, so volcanic mountains will be formed, it will be behind, and also other mountains will be formed. This mountain is uplifted form of the melange or accretionary wedge, and these are also called as the trans Himalayas, because these are formed even before the formation of the Himalayas. So these have been formed before the tertiary times. They have been formed below 70 million years behind, before. That's today they are in the form of the trans Himalayas. So that's why in Karakoram you will be having volcanic rocks. So within Karakoram range you have Rakaposhi range. The Rakaposhi range will be having volcanic rocks but not active volcanism, because Tethys Sea is not present between India and Eurasia. And today such example you can find in the Rockies and Andes. So this is the Andes. So this is a Nazca plate. Nazca plate is undergoing subduction. When it is undergoing subduction, you have the Andes mountain, and Behind, okay, within this Andes mountain, you will also have active volcanoes, such as you have Cotopaxi, Chimborazo. These are there in Ecuador. So here you have Ojas del Salados. It's also a mountain. Here you have Mount Aconcagua. You don't have to remember these, not required. They are not in the news recently. And coming to North America, the Rockies are also formed because of the same process. That's when Rockies, you will be having such volcanic mountains, such as Mount Denali. ये ध्यान रखना नाम, ये याद रखो, Mount Denali. So Denali you have to remember, because earlier, okay, it was called as Mount McKinley. So there is a name change here. That's why it is called as Mount Denali. You also have Mount Rainier. You have Mount Shasta. Okay. You have Saint Helena. So these are some of the volcanic mountains which are present here. Okay. So once upon a time, the Trans Himalayas are also such kind of mountains. Okay. So this is about the OC-CC collision. So next comes the CC-CC collision. So this is the CC, this is the OC, it will be undergoing subduction, and here you will be having mountains. So you will be having volcanic mountain also, and somewhere you will be having a CC here, and finally this ocean will have lot of sediments. So imagine this as the Tethys Sea. Imagine this as Tethys Sea. Imagine this as the Indian plate, and imagine this as the Eurasian plate. This as the Eurasian plate. So finally, when the Indian plate is moving forward, the Tethys Sea sediments which will be there, they will be finally uplifted. So finally, you will have the CC-CC collision like this. So the Indian plate will finally collide with the Eurasian plate, and of course, you already have this Trans Himalayas which are formed, and behind in Karakoram will be having volcanic rocks also, and the fresh sediments, they will be uplifted in the form of Himalayas. They will be uplifted in the form of the Great Himalayas and the Middle Himalayas. So that's why these mountains are called as Trans Himalayas. But Trans Himalayas are, okay, the Janskar, Ladakh and Karakoram. This is the Great Himalaya and this is Middle Himalaya. The Shivaliks is not even a true fold mountain. It's not fold mountain. It is nothing but uplifted debris. So this is how the Himalayas have been formed. But here what happened in case of India is, Indian plate has undergone little bit of under thrusting below the Eurasian plate. So thoda Eurasian plate uplift ho gaya. Generally it should be like this. There should be head on collision between two plates. But here Indian plate has uplifted the Eurasian plate. So that's why you will have the change in the height here. So this is where the Tibet is, and this is where you have Karakoram, and here you have Ladakh Janskar, and this is the Great Himalayas. The Great Himalayas will be having, Great Himalayas has orthoclinal fold. Great Himalayas will be having orthoclinal fold. It's also called as the hogback structure. Hogback structure. So it is making a 90 degree, and right now all the forces are acting here on this Middle Himalayas. That's why Middle Himalayas are overturned. So, middle Himalayas are an example of the overturned folds, and middle Himalayas are also have lot of reverse faults, means there is lot of compression which is associated with middle Himalayas, and also of course the great Himalayas also have lot of compression, and these are made up of sediments. Now when a rock is made up of sediments, do you think these are sedimentary rocks, do you think they will be strong? No, they will not be strong. Now you must have heard about the land subsidence in Joshimath. क्यों हो रहा है? Because Joshimath is located in the Himalayas. So the rocks below, they are not stable rocks, they are unstable rocks. And when the groundwater is extracted or when the dams are constructed, these rocks will become comparatively soft, and over that if you are doing heavy construction, then the land will collapse, the land will subside. So that is what is happening in Joshimath. Okay, it is associated with groundwater extraction, heavy construction, sedimentary rocks of marine origin which are not very hard, and also lot of hydrological projects. We will discuss all those names later. Lot of dams are constructed in this vicinity, and also lot of highway construction is taking place in those places. I will show you all the maps later on when it comes. Asa is asking, what is the example of CC-CC collision? यही तो है CC-CC collision. Himalayas are the example of CC-CC collision. Invincible. अब क्या पूछ रहे हो? You are asking me why the Rockies are formed on the coast, because subduction is taking place, that is why they are formed on the coast. Okay. So these are the three types of the plate interactions, and this is all about the plate tectonics. Now let us talk about the volcanism here. Now look at the mountain, look at the volcanism. Now look at the shape of the mountain and tell me which kind of a mountain is this. So this is located on the border of the oceans, or it is located on the margins of the oceans. This is highly explosive because the magma is acidic in nature. The magma is sourced from the upper superficial layers, and it is also associated with lot of water vapor, and such kind of volcanoes are found on the OC, oceanic crust interaction, and oceanic crust continental crust interaction. So this is also highly explosive in nature. So this is where the crater is getting converted to caldera, and lot of material is also released while this explosion is taking place. We will see what all kinds of material are released. See, sometimes only lava is released, and along with lava you can see lot of rocks which are coming out. These rocks are called as burnt rocks, and these rocks are also called as pyroclast. The burnt rocks are called as pyroclast, and here volcanic bombs and lot of ash is also released. In some volcanoes only ash will be released. Look at this, this is highly conical in shape. So in this ash is also released, lot of vapor is also being released. Now look at this, it is highly fluidic in nature. So this is the basic lava. This lava is released from the hotspot such as Hawaiian hotspot, such as Afar triple junction, because this is sourced from the deep interiors. It is not exploding like this, it is flowing in the form of a river, because this is highly fluidic in nature. Look at this, it is also fluidic in nature. So by looking at the volcano only you can tell from where it is sourced. Okay. Now let's see various volcanic landforms. Various volcanic landforms. The landforms can be extrusive, they can be intrusive, extrusive and intrusive. So, extrusive landforms, you can have basic lava, you can also have the acidic lava. Acidic lava will always come from the central vent. It will always come from the central vent, and they will be having conical shape, and this is associated with OC-OC collision and associated with OC-CC collision. Means OC-OC means say Japan type, and say this is like Rockies or Andes. Then basic lava, it can come from a central vent, it can come from a central vent, it can also come from a fissure. If it is coming from a central vent, since it is highly fluidic in nature, it will flow very long distances. पानी की तरह बहेगा. It will not form a conical shape, rather it will form a dome shape, or it will also form a shield shape. Next you have fissure. Fissure means crack. So from the crack you will have volcanic eruption from both the sides. So this will create extensive lava sheets. This will create extensive lava sheets. An example of this is, just now you have seen Ethiopian Highlands. Ethiopian Highlands are the example of this. Ethiopian Highlands are created along the Great African Rifting. And also second example of this is the Deccan Traps of India. Other examples are also there. Deccan Traps hai. Kimberley Plateau in Australia, Colombian Snake River Plateau in USA, Patagonian Plateau, okay, in South America, Antrim Plateau in Ireland. So these are the various examples. And dome or shield from the central vent. So here the examples are hotspots, such as the Hawaiian hotspot, Reunion hotspot, Galapagos hotspot. Okay, so since we are discussing about the hotspots, okay, I will talk about certain locations. See, so this is where the Hawaiian hotspot is. Hawaiian hotspot. So Hawaiian hotspot is active now. आप अगर यहाँ पे जाओगे तो यहाँ पे आपको दिखेगा वोल्केनिज्म बाहर आते हुए. And the name of the mountain is Mauna Loa. And इसके जस्ट ऊपर ना, जस्ट पास में या माउना किया. माउना किया के नीचे पहले एक्टिव था वोल्केनो, लेकिन प्लेट शिफ्ट हो गया, इसलिए अभी हॉटस्पॉट माउना लोआ के नीचे एक्टिव है. एंड माउना किया के ऊपर आपको बहुत सारे टेलीस्कोप्स दिखेंगे. क्यों? बिकॉज फर्स्टली दिस इज ए आइलैंड फार अवे फ्रॉम पोल्यूशन. You will be having clear skies, so you will be able to observe the universe in a better way, and it's also away from radiational pollution. That's when Mauna Kea you will find lot of space observatories. जो ब्लैक होल को देखा था ना, M87 ब्लैक होल को, okay, Event Horizon Telescope is a combination of 8 telescopes, and one of the telescopes is located here on Mauna Kea. And this is also the example of the plate tectonics. So all these group of islands have been created because of Mauna Loa. You can see a chain of islands. This is called as Emperor Seamount. ये आपको याद रखना है, क्योंकि अभी फिलहाल रिसेंटली Mauna Loa is having lot of eruption, active eruption, and previously in the geological time scale this was also created by the hotspot, and बीच में Midway Islands है, Midway Islands, and here you have Hawaiian group of islands. Since this is in the news, you should remember Midway also, you should remember Emperor Seamount also. I hope this is visible to you. सी के पीछे दिख रहा है आपको कुछ आइलैंड जैसा कुछ विजिबल ना? ओके, यस, आई विल डू लिथियम डिपॉजिट ऑल्सो, आई विल डू, डोंट वरी. सी जो यू नो कॉन्टेस्ट के साथ साथ जो भी आ रहा है ना, मैं उसका करंट अफेयर्स ही कर रहा हूं मैं. निशांत, आई विल डू लिथियम डिपॉजिट इन हिमालय. क्यों होगा मैं ज़रूर बताऊंगा. इनफैक्ट मैं ये है नहीं, आई विल नॉट जस्ट टेल यू द फैक्ट, आई विल टेल यू द रीज़न ऑल्सो बिहाइंड इट. जब तक रीज़न नहीं होगा मैं डिस्कस नहीं करता हूं मैं. चलो, थैंक यू, थैंक यू एवरीवन. सो दिस आर द हॉटस्पॉट्स. अगेन यहाँ पे एक हॉटस्पॉट है ऑफ द कोस्ट ऑफ साउथ अमेरिका. हियर यू हैव अ हॉटस्पॉट. This is called as Galapagos hotspot. So Galapagos hotspot is famous for Charles Darwin theory of evolution. So Charles Darwin has come here, he has done all the experiments. And why Charles Darwin? Okay, see, you must have been observing me. मैं हमेशा रीज़न बताता हूँ, बिना रीज़न का कुछ नहीं बताता हूँ. तो चार्ल्स डार्विन यहाँ पे क्यों आया, गैलापागोस पे क्यों आया? फर्स्टली इट्स एन आइलैंड. इफ़ यू वांट टू स्टडी द एवोल्यूशन, आपको उसी जानवर को पढ़ना पड़ेगा जो वहाँ पे एवॉल्व हुआ है. यू कांट चूज अमेजोन फॉरेस्ट, बिकॉज अमेजोन फॉरेस्ट में जो जानवर है वो कहीं से भी आ सकता है ना. इट मस्ट हैव माइग्रेटेड देयर. देन यू वोंट बी एबल टू स्टडी इट्स एवोल्यूशन इन दैट क्लाइमेटिक कंडीशंस. नाउ हियर इफ यू आर हैविंग रेप्टाइल्स, if you are having mammals, then there is a very high probability that they must have been born here only. So you can study the evolution in a very easy way. So that's why he has chosen Galapagos. Now he could have chosen any island. Why he has chosen the island on the equator? This island is present on the equator. क्यों? Because equator के ऊपर biodiversity बहुत high होता है. Away from the equator, the biodiversity decreases. Why near the equator biodiversity is high? Biodiversity is dependent upon the amount of the food available, primary productivity available, and primary productivity is dependent upon rainfall and nutrients. Basically यहाँ पे rainfall बहुत ज़्यादा होता है equator के ऊपर. So that's why he has chosen this island. Okay. Acha, Nandini, you're also there online. All my previous students are haunting me here. Good. लेकिन यहाँ पे you know एक इंटरेस्टिंग चीज़ भी हुआ यहाँ पे. So यहाँ पे एक कंट्री भी है, so called country. It's called as the United States of Kailasa. ये सुना होगा आपने, स्वामी नित्यानंद. ही इज अपस्कॉन्डिंग फ्रॉम इंडिया, तड़ी पार भाग के यहाँ पे चला गया. यहाँ पे एक आइलैंड खरीद लिया एंड आइलैंड का नाम रखा यूनाइटेड स्टेट्स ऑफ कैलासा. दिस पीपल हैव रिसेंटली सीन द यूएन ऑल्सो. यूएन के असेंबली में बैठे थे ये लोग, दे आर वेयरिंग ए वियर्ड कॉस्ट्यूम एंड दे आर सिटिंग देयर एंड दे हैव एक्यूज्ड इंडिया. And they also signed an agreement with a city called as Newark. Newark एक city है न्यूयॉर्क न्यू जर्सी के पास. Okay, like in India we have sister city agreements. Means for example Kyoto in Japan, it will be helping city Varanasi. Okay, these are called as sister city agreements. So yes, these people have signed an agreement with Newark also. Newark was about to give them money, पर बाद में पता चला ये तो पूरा scam है. So that is the funny part. about this region. Okay. Okay, ये हॉटस्पॉट है. यहाँ पे अगेन सी अकॉर्डिंग टू द कॉन्टेक्स्ट आई एम टेलिंग यू, हॉटस्पॉट्स आया इसलिए हॉटस्पॉट्स के बारे में बता रहा हूँ मैं. तो यहाँ पे और एक हॉटस्पॉट है, दिस इज रियूनियन हॉटस्पॉट. रियूनियन, it is located off the coast of Madagascar. Now Reunion hotspot is responsible for creation of Mauritius also. Mauritius. It is also responsible for creation of Chagos Lakkadivi Ridge. Chagos Lakkadivi Ridge. So in Chagos Lakkadivi Ridge you have Diego Garcia. Diego Garcia. Diego Garcia belongs to UK. UK की टेरिटरी है, but it has USS Air Base. It has USS Air Base. And above this you have Maldives. Maldives here. And also you have Lakshadweep here in this region. Please remember this, Diego Garcia, because it was in the news 4 to 5 years ago when the MH370 Malaysian Airlines had disappeared. The Malaysian Airlines, okay, MH370, it was supposed to fly from Kuala Lumpur to Beijing, उसका रास्ता ये था, लेकिन वो फ्लाइट पता नहीं यहाँ पे आके भटक गया था. So there were a lot of conspiracy theories regarding this. Diego Garcia. मालदीव्स में इंडिया का एक प्रोजेक्ट है, दैट ऑल्सो आई शो यू. एंड यू हैव लक्षद्वीप हियर. द फर्स्ट, ओके, लेट्स टॉक अबाउट ऑल दिस कंट्रीज. सो दे हैव बीन क्रिएटेड बिकॉज ऑफ द रियूनियन हॉटस्पॉट. एंड द डेक्कन ट्रैप्स ऑफ इंडिया, even these Deccan traps of India have been created because of this reunion hotspot. So when the Indian peninsular plateau, when this Indian peninsular plateau, we're looking for something. So पहले इंडिया यहाँ पे था, अंटार्कटिका में था. While it was moving over reunion hotspot, so reunion hotspot has punctured India. Indian peninsular plateau को ऐसे काटा. Then India was moving forward. When India was moving forward, hotspot तो वहीं पे रहेगा. It is stationary. So it has created a divergence here. It has created a faulting here. And because of the faulting, part of the peninsular plateau has been broken. And this peninsular plateau which has been broken, western flank of the peninsular plateau, okay, it got broken because of the rifting. And then it fell into the ocean. ये जो टूटा हुआ पार्ट है ना, ये ओशन के अंदर गिर गया. So that's why you have a very broad continental shelf. This light blue portion में जो दिख रहा है, this is the continental shelf. That's why you have a broad continental shelf on the west as compared to the east. So this is basically made up of a continental rock. Now talking about Diego Garcia, so this is British Indian Island Territory. So you'll see the air base of USA here. यहाँ पे आपको एयर बेस दिखेगा आपको. See, you'll see the air base of USA. Then, but यहाँ पे USA का एयर बेस है, USA का प्रेजेंस है. देन आप मुझे पूछोगे सर इंडिया का नहीं है क्या? क्या चन्ना मेरा ईयर ऑल्सो देयर. So Amit is asking Nityanand Island then any, yes, visa free entry मिलेगा आपको वहाँ पे, जो भी जाना चाहे, anybody who wants to go there can go. Okay, they follow pure Indian culture, no मिलावट at all. So you can ask, sir, this is all Indian Ocean है, USA का एयरबेस है, then इंडिया का एयरबेस नहीं होना चाहिए क्या? Yes, India also has air bases. Air bases नहीं बोलेंगे, air strips है. Okay, India also has air strips. Okay, one is there in Assumption Island. Assumption Island. This Assumption Island belongs to Seychelles. Assumption Island belongs to Seychelles. And you have here, you have Agalega Islands. Agalega. Agalega Island, it belongs to Mauritius. Belongs to Mauritius. So India has presence in the Indian Ocean also. But यहाँ की हालत उतनी अच्छी नहीं है. This is India's airstrip. आपने अभी अमेरिका का देखा का कितना अच्छा है, इंडिया का देखो बहुत ही खराब हालत में है. एंड मोर ओवर ना, ये जो कंट्रीज है, मॉरिशस है, सेशेल्स है, अग्री नहीं करता है कि इंडिया के यहाँ पे कुछ बेस है, कुछ है, बिकॉज वो बोलेंगे कि इंडिया के यहाँ पे एयर स्ट्रिप्स है, एंड चाइना को गुस्सा आएगा, चाइना विल फील एंग्री. दैट्स वाई वी डोंट ऑल्सो ऑफिशियली अग्री दैट वी हैव समथिंग हियर. एंड मोर ओवर इसकी हालत देखो तो नहीं बोल सकते ना ये हमारा है, कितना अच्छा बनाया देखो, नहीं ना. लेकिन इसके ऊपर, असम्पशन आइलैंड के ऊपर, वन मोर आइलैंड इज देयर. दिस आइलैंड इज कॉल्ड एज आल्डाब्रा आइलैंड. आल्डाब्रा आइलैंड में टर्टल्स है, बहुत बड़े बड़े, लार्ज, मेरे साइज के टर्टल्स होंगे यहाँ पे. एंड इट्स ऑल्सो यूनेस्को वर्ल्ड हेरिटेज साइट एंड इट बिलोंग्स टू सेशेल्स. एंड नेक्स्ट, here you have Comoros island called as Comoros, which belongs to France. Reunion, it also belongs to France. Mauritius is a separate country. This is Seychelles. Seychelles is also a separate country, along with Madagascar. Madagascar, okay. So all these are part of Indian Ocean Commission. All these are part of Indian Ocean Commission, in which India is trying to enter. India का यहाँ पे observer status है, okay? ये ध्यान रखना. So this is all about this region. And recently, okay, why I'm mentioning all this, because recently China has renamed 11 locations in the Indian Ocean also. उनका नाम याद रखने की जरूरत नहीं, यानी तो चाइनीज नाम होंगे, वियर्ड नाम होंगे, you don't have to remember. But since China is renaming the locations here, you have to know about Indian Ocean. इसके अलावा और कुछ जानने की जरूरत नहीं. Okay, one more thing here. यहाँ पे एक आइलैंड है called as Socotra. Socotra belongs to Yemen. Okay. हिंदी में भी पढ़ाना है. Okay, fine. My Hindi is very poor. Please excuse me for that. Okay. So these are the various features of the Indian Ocean. So we have started from hotspot volcanism, right? So these are the hotspots, and because of the fissures, okay, you have Ethiopian highlands, okay, like Deccan Traps. Ethiopian highlands you have seen, you have to remember Tigray there, Tigray region. And because of acidic lava, okay, since different types of materials are released, sometimes ash is released, sometimes lava is released, sometimes only, okay, water is released. So because different types of material are released, These volcanoes are also called as stratovolcanoes. कभी सिर्फ पानी आता है, कभी ऐश आता है, सिर्फ ऐश, कभी लावा आ जाती है. So since they are made up of different materials, they are also called as composite volcanoes. Since they have various layers, they are also called as stratovolcanoes. Stratovolcanoes or composite volcanoes. Okay. So generally these volcanoes have conical shape. They have acidic lava. They have acidic lava. Generally, they will be having acidic lava. That's why they are conical in shape, right? And generally, these are explosive. They are explosive. And the mud flows here. Mud flows are called as lahars. Lahars. Mud flows are called as lahars. The tephra, the pyroclastic material. Pyro means fire, clastic means rock. These are nothing but burnt rocks. These burnt rocks, they are also called as tephra. And tephra differs in terms of size. बहुत ही small size है, okay, less than 2 mm. This is called as ash. 2 to 64 mm. 2 to 64 mm. It's called as lapilli. Lapilli is P-shaped rock. P-shape means मटर जैसा होता है, छोटा छोटा पत्थर होता है मटर जैसा. It is called as P-shaped rock. And greater than 64 mm. This is called as volcanic bomb. अभी मैंने आपको दिखाया था volcanic bomb. I'll show you all these types. See, so lava is coming. इसमें से पत्थर आ रहे हैं. They are volcanic bombs. Okay, and this ash is released. Lot of pyroclastic material is released. This is volcanic ash. And this lot of fumes, lot of gases are released. Okay, this is lava. So these are the various shapes of volcanoes, right? The different kinds of materials are released here. We'll come to this. Now this is called as the pumice rock. This is called as the pumice rock. So when the lava is coming out, so along with the lava, if there is very large amount of water vapor, so initially the water will be there. So as the rock is cooling over a period of time, the water vapor and the gases will escape outside. So while freezing, there are a lot of pores which are left behind. Such kind of rock is called as the pumice rock. It's a volcanic rock. And this volcanic rock का देखो, this volcanic rock floats in the water. पानी में फ्लोट करता है बिकॉज इसमें बहुत सारा एयर स्पेसेस है एंड बिकॉज ऑफ दिस एयर स्पेसेस इट इज एबल टू हैव द बॉयंसी. So basically, you know what Ramayana, when you read, okay, you must have heard about this rock which is used for building this Ram Setu bridge. Okay, that is this rock only. This is pumice rock. Okay, acha, it's also used in aquarium? I don't know that. I am not that rich to have aquarium at the home. मेरे को खुद को खाना नहीं मिलता, मच्छी को क्या दूँ मैं खाना. Okay. And अगर मैं, you know, if you are doing something, you know, fast ना, doesn't, okay, it means that it is not important for this year's examination. And for this year's examination, something is more important, then I'll go slow, don't worry. So next, see, you'll be having a lot of country rocks. These are called as country rocks. Basically, these are the sedimentary rocks which are made up of different layers. Means ये ऐसे कुछ rocks है. Okay, different layers of rocks will be there. So this, in between these layers, you'll be having joints, right? So when the volcanic eruption is happening, when the volcanic eruption happens from here, now if it is finding a weak point here, if it is finding a joint here, then it will start flowing along this joint and will get deposited on the synclines and anticlines. This is called as the anticline, this is called as a syncline, and it will be creating lens shaped rock, and this lens shaped rock is called as facholith. It's called as facholith. Now while rising up, again this will be deposited here in this depression. Depression में deposit हो जाएगा. Then this is called as this saucer shaped rock, and this saucer shaped rock is called as lopolith. You can have these vertical intrusions also. These vertical intrusions, these are called as dikes, and the horizontal intrusions, these are called as sills. And above this, of course, you can have this volcanic mountain. So generally, volcanic mountain के नीचे you'll be having all these features. So I don't think any of this is important this year. By the way, if you want to see how this looks like, dike looks like, so this is a real picture of the dike. You can see we will have a vertical intrusion between the country rocks or primary rocks or sedimentary rocks. So these are the various landforms associated with volcanism. Okay. And one very important feature is crater to caldera. Crater to caldera. So when you are having this volcano, so below this you will be having magma chamber. You will have magma chamber, and when this it is rising, it will be having a lot of parasitic cones also. Or so from the magma chamber, the magma will be oozing out. Basically, it will break the mountain from all the sides. Okay. So finally, what will happen is that, okay, this magma will recede back. Okay, and the magma chamber will be emptied. So earlier, okay, the magma was intruding, it is breaking this rock, and finally, okay, you are withdrawing this. When you withdraw this, now various cracks are created in this. So because of the creation of the cracks, now what will happen? It is unable to withstand the weight. So when it is unable to withstand the weight, this will break. ये पूरा collapse हो जाएगा. Okay, so earlier this was crater, and this crater is converted to caldera. So either the collapse of the crater is converted to caldera, or when the crater is blown away, sometimes what happens is that the magma will be coming from below, so the push will be so hard, the push is so hard that this part will be blown away completely. So ऊपर का part अगर उड़ जाता है, if it is blown away, then also the caldera is created. So recently, आप बताओ मुझे कहाँ पे the crater has been converted to caldera and there was a very huge explosion. Last 2 years में कहाँ पे हुआ है? Okay, मैं ही बता देता हूँ. Recently it has happened in Tonga Islands. Just now we have discussed Tonga. So this has happened in Tonga Islands. Tasmia is asking, if this is used in Ramayana, will it take the destiny of the people? Okay, I don't know. I stay away from religion. मुझे पता नहीं ये सब चीज़ें. मैं ज्योग्राफी क्या है उसमें मैंने बता दिया. अभी लोगों का क्या है, I don't know. I'm sorry. So these are the various landforms created because of the volcanism. See, आपको बस ये वाला टेबल याद रखना है. ओके, सो कोनिकल शेप में एसिडिक लावा में क्या क्या क्रिएट होगा. सो यू शुड नो व्हाट इज लहर, you should know what is lapilli, you should know what is crater, you should know what is caldera, composite volcano or stratovolcano, what is volcanic ash. Now if your mountain is completely covered with ash, okay, that is also called as cinder cone. Cinder cone. Now, what are the intrusive formations? Intrusive formations are of two types. One is hypabysal formations. Hypabysal means just below the surface. Just now you have seen laccolith, lopolith, sills, dikes, phacolith. Okay, and you also have plutonic rocks. The plutonic rocks are formed very deep inside the earth, and these are called as batholiths. So that's it. So entire volcanism or volcanic landforms can be prepared in a small chit on a single sheet of paper. Amit, yes, okay, I did not come to Patna Center. Ramesh, चलो. So volcanic landforms आपने देख लिया. Now regarding the earthquakes now. Earthquakes. See, first let's discuss the earthquakes due to divergent plate boundary. So, in a divergent plate boundary, the magma which is coming out is coming from deep earth interiors. It is highly fluidic in nature. It won't disturb the crust much. Crust को ज़्यादा हिलाएगा नहीं. जो crust को ज़्यादा हिलाएगा, then that will cause earthquakes. जैसे ये हुआ. See this or this. So these are the explosive volcanoes. So when they are coming out, they come up with a huge force. These are associated with acidic lava. So when the explosion takes place, the crust will shake. Okay, the crust has to shake for the earthquake to happen. So the divergent plate boundary will not create any earthquakes. If at all it is creating earthquake, the earthquakes will be having very low intensity or very low magnitude. Next, convergent plate boundary. So in a convergent plate boundary, you have collisions. Not only collisions, along with the collisions, you also have this volcanism. Along with the collisions, you also have this volcanism. So there is a friction when this subduction is taking place. Okay, when this oceanic plate subduction is taking place, there is a friction between these connectors. Say this is the CC or OC, and this is the oceanic plate which is undergoing subduction. So between these two, there is a friction. कहीं अटक जाएगा है. Okay, then वहाँ पे stress generate होगा. And the stress suddenly release होता है ना, then the earthquake is triggered. So it is generated because of the friction, also because of the volcanic eruptions, and this which are highly explosive in nature. So this is due to the convergent plate boundary. Okay. And when you have CC-CC collisions, these collisions are happening head on. So there is a lot of force which is associated with this, and this force, okay, can get accumulated over a period of time, and suddenly when the stress is developed over a period of time, the plates are moving towards each other, कहीं बीच में अटक जाता है, फिर और स्ट्रेस जनरेट होगा, and ये पूरा स्ट्रेस एक ही बार में रिलीज होता है, and that will lead to the shaking of the crust, that will lead to the disturbances in the crust, creating earthquakes. So this is at the convergent plate boundary. And next you have transform plate boundary. These are also called as slip faults. So when the plates are sliding past each other, again बीच में क्या अटक जाता है? This is called as interlocking. So because of the interlocking, the stress is generated, and because of the stress also, the earthquakes can be triggered. Okay. Now we'll discuss about these three types of earthquakes. So divergent plate boundary, example is Great African Rifting. So along the Great African Rifting, okay, you have volcanoes, you have active volcanoes. Recently one volcano was observed, okay, recently Goma, a city called as Goma, had a active volcanic eruption because it is located on the divergent plate boundary. यहाँ पे Goma है, Goma is located. The Goma belongs to Democratic Republic of Congo, DRC को belong करता है. Okay, and in between you have this lake Kivu, and on this side you have Rwanda. So Rwanda, once upon a time, it had ethnic clashes between two groups called as Hutus and Tutsis. दोनों के बीच में genocide हुआ था, okay, Tutsis का. They were seen like cockroaches and they were killed. So that's why it was in the news, Rwanda. And this is Lake Kivu, and this is city Goma. And this is DRC, Democratic Republic of Congo, DRC. So DRC के नीचे you have Katanga Plateau. This Katanga Plateau is very rich in mineral resources. So that's why DRC also has numerous conflicts. There are mercenaries, there are warlords, because इतनी बड़ी country को एक center से manage करना मुश्किल होता है, especially in the societies like that of Africa, which has forest, which has grassland. And forest में grasslands में जो community होती है वो tribal communities होती है, नहीं तो nomadic herders होते हैं. Nomadic herders means वो बकरी चलाने वाले, गाय चराने वाले. They are there in the grasslands, and in the Congo basin you will be having forest. So here you will be having tribal communities. So they are in isolation, and suddenly उनको आके बोल रहे हो आप, because ये लोग अभी बाहर ही नहीं आए जंगलों से, and suddenly आपके यहाँ पे आके बोल रहे हो you all belong to the country of Democratic Republic of Congo, okay, stand up and sing national anthem. ऐसा बोलोगे उनको समझ में नहीं आएगा क्या बोल रहा है, कहना क्या चाहते हो. इसलिए ऐसे सोसाइटीज़ में या ऐसे कंट्रीज़ में एक फीलिंग ऑफ नेशनलिज्म लाना बहुत ही डिफ़िकल्ट होता है. So that's why you have in Africa you have numerous conflicts between various groups because there are so many tribals. So African conflicts are evergreen, हमेशा होता है. We'll talk about Sudan also. Sudan में क्या conflict हो रहा है उसकी बात भी करेंगे, and ये क्यों conflict हो रहा है, we'll talk about that also. And the southern part of this Democratic Republic of Congo, you have lot of minerals, especially, okay, Democratic Republic of Congo has coltan. Coltan is used in mobile devices, it's used in high-end electronic instruments. It also has cobalt. Cobalt is used in lithium ion batteries. Why cobalt is used in lithium ion batteries, I'll explain later. ये दोनों मिलता है यहाँ पे, and these are highly valuable for the today's electronic industries and electronic revolution. So that's why, okay, these minerals are also reasons for the conflict. and this is called as resource curse, means if you have resources you have cursed. So again here Uganda is there. Okay, Uganda is located beside Democratic Republic of Congo. So beside Uganda, okay, this is all part of the Great African Rifting है, पूरा rifting का part है. And जब भी rifting होता है ना, rift के दोनों side you will be having, okay, the block mountains, also called as the host, also called as escarpments. And between Uganda and Democratic Republic of Congo, you have a mountain called as Rwenzori Mountains. We will discuss later why Rwenzori, because Rwenzori is one of the sources of the river Nile in this region. Okay. Anyways, you have seen the lakes here. Okay. So along the Great African Rifting, you will be having volcanism, but not earthquakes, because the magma or the lava associated with it is very silent. It will not disturb the crust much. Next, the the earthquakes along the convergent plate boundary. The Himalayas is a very classic example of this. So along the Himalayas, in the Alps, in Rockies, in Andes, you have this earthquakes. And along the transform plate boundary also, you will be having earthquakes. Now talking about the transform plate boundary, recently there was an earthquake in Turkey. Okay. Now let's see the different plates over here in Turkey. So here in the northern part of the Turkey, this is North Anatolian fault. This is North Anatolian fault. Here between Turkey and Syria, you have East Anatolian fault. East Anatolian fault. And down south, here you have Dead Sea fault. You have Dead Sea fault. Okay. See, all the three faults, they are all transform faults. They are all transform faults. And the recent earthquake in Turkey and Syria is along this East Anatolian fault. See, the Dead Sea fault also has the features of divergent plate boundary. Okay. And East Anatolian fault has the properties of compression also, convergent plate boundary. But it is more of a transverse fault. It's actually called as transpressional faults. Means this movement, it also has compression. It's called as transpressional. लेकिन आपको इतना deep जाने की ज़रूरत नहीं, और simply आप ये याद रखो, transform faults or 3 transform faults. And see, यहाँ पे भी एक plate boundary है. This is a convergent plate boundary. So on the north of this convergent plate boundary, so this is all Eurasian plate, a पूरा Eurasian plate है. इधर Arabian plate है, this is Arabian plate, and नीचे है African plate, African plate. So this is African plate, this is Arabian plate, and this is Eurasian plate. And in between these three, again here you have a triple junction. You have a triple junction. And the recent earthquake is near this triple junction. Okay. And the earthquake has took away around 60,000 lives in Turkey. These are the official estimates. इससे ज़्यादा ही मरे होंगे, लेकिन टर्की इतना बताता है. And in Syria the deaths are around 10,000. So we'll also see why such a difference, okay, in this death toll. एक कंट्री में ज़्यादा मरे, एक कंट्री में कम मरे, क्यों ये देखते हैं. Okay. See, when this subduction will be taking place, the earthquake can happen anywhere. Earthquake can happen anywhere. It can happen due to the friction between the OCC. It can happen due to mantle slab friction, because when it is plunging into the mantle, there is a friction. This is called as mantle slab friction. And also, finally, when this plate is undergoing melting, so here the slab will be fracturing and it undergoes melting. Finally, from here, the volcanism will be coming. So here also the earthquake can be triggered. This entire zone, this is called as the Benioff-Wadati zone. Benioff and Wadati are the two scientists who have created this. This is called as Benioff-Wadati zone. And let's talk about the measurement of the earthquakes, how the earthquakes are measured. So earthquakes can be measured, okay, in terms of the magnitude. Magnitude is nothing but the movement, it is the amplitude. Basically, कितना हिल रहा है? What is the movement? ये कितना हिल रहा है ऐसे? Okay, this is completely objective in nature. You measure, I measure, PM measures, और नवाज शरीफ measures, और ट्रंप measures, कोई भी measure करेगा, ये तो same होगा. Machine वही record बताएगा. So it measures the magnitude, or it's called as the amplitude, and the scale which is used is called as the Richter scale, and the improvised version, it's called as the moment magnitude scale. So this is objective in nature. Whereas the other way of measuring the earthquake is in terms of intensity. Intensity means कितने लोग मरे, कितने लोगों का हाथ पैर टूटा, कितना बिल्डिंग्स डिस्ट्रॉय हो गए, कितना प्रॉपर्टी डैमेज हो गया, एंड कितने लोग मेंटल ट्रॉमा से गुजर रहे हैं. Now this is subjective. Somebody might take this post-traumatic stress disorder into account. Somebody may not take. Somebody will be taking into account only the death toll. कितने लोग मरे. If somebody's hand is broken, leg is broken, पूरा ही गया, लेकिन बस जिंदा है. Okay, then that will not be taken into account. Therefore, it all depends on the person. It all depends on the government. So that's why this is subjective in nature. And this is called as the Mercalli scale. Mercalli scale. So such kind of a scale is used by Japan. So Japan will be using such kind of a scale, because this scale is very appropriate for those countries which have almost uniform development. Now, आप अगर इंडिया में यूज़ करते हो मर्काली स्केल से, सेम मैग्नीट्यूड है, रिक्टर स्केल में 6 है, और दिल्ली में आया, राजस्थान डेजर्ट में आया, सो कहाँ पे होगा ज़्यादा डेथ टोल? दिल्ली में होगा, राजस्थान में एक भी नहीं मरेगा. नाउ टॉकिंग अबाउट टर्की एंड सीरिया. In Turkey you had 60,000 deaths, but in Syria you had only 10,000 deaths. Means वो border में आया, epicenter was almost on the border, and density of population is also same on either sides. But Turkey में ज़्यादा buildings थे, Syria में नहीं थे. So it is the buildings which has killed the people. It's not the earthquake which kills the people. The buildings were in bad shape. The buildings were in dilapidated condition. The construction quality is not good in the building. That's why the people have died in Turkey. So there you can't use Mercalli scale, because city में अलग अलग हो सकता है. So you are going to a rich locality, there the building code is good, the buildings are constructed with a very good quality cement and pillars, everything. उसमें what they can also withstand the Richter scale 10. So not even a single death will happen. से उसके साइड में कोई गवर्नमेंट की कॉलोनी है, वहाँ पे भी उन्होंने बिल्डिंग कंस्ट्रक्ट किया, वहाँ पे सारे बिल्डिंग गिर जाएंगे. सो वहाँ पे इंटेंसिटी ज़्यादा होगा. लेकिन दोनों ही साइड बाय साइड है, एक ही सिटी में है, एक ही जगह में है, लेकिन इंटेंसिटी अलग अलग है, मैग्नीट्यूड सेम होगा. सो दिस इज रिगार्डिंग द मैग्नीट्यूड. इन मेंस आई कैन एक्सपेक्ट दिस क्वेश्चन, ये पूछ सकता है. नाउ द मेजर्ड रिक्टर स्केल इज मेजर्ड in terms of logarithmic scale, log 10 amplitude. It means that if there is a movement of 10 centimeters, 10 centimeter हिल रहा है और रिक्टर स्केल में 1 माना जाएगा. अगर वो 100 सेंटीमीटर हिल रहा है, then it will be considered as 2. अगर 1000 सेंटीमीटर हिल रहा है, it will be considered as 3. So this is the logarithmic scale. So Richter scale and moment magnitude scale will be using the logarithmic scale, and ये होगा 4, 5, 6 etc. Now the energy released, so the amplitude is increasing by 10. Amplitude means nothing but हिलना. It increases by 10, 10x बनेगा. What about the energy? Energy becomes 30 times, almost 30 times, 30 to 32 times. Means अगर इसमें 1 kg RDX यूज कर रहे हैं, ओके, इसमें 30 kg RDX का एक्सप्लोजन होगा. इसमें 900 kg RDX का एक्सप्लोजन होगा. So energy released becomes 30x. Okay, on the Richter scale. Understood? So these are some of the terms associated with the earthquakes. So there is one more term called a seismic gap.